Good morning, students. Welcome to day one of your June holiday boot camp. Now, everyone's enjoying your holiday, right? So let's have some fun with the questions today. We are going to have critical thinking questions as well as those typical exam questions as well, okay? So everybody, think out of the box, okay? Open up your mind and let's have fun today. So students, let's take a look at question number one. Now, this is a critical thinking question where you have to spot the pattern, right? Now, if you look at this, students, now as you know, what are operators? Operators are plus, minus, times, and divide. Okay, so these are operators. We all recognize them, but now they're giving you a new operator that you have never learned before. So it is up to you to use your imagination and pattern spotting skills to see how it works, you know. So for example, if you have 3 star 4, the answer is 5. 5 star 6, then you get 19. 4 star 7 is 17. What kind of pattern is this? Why not you take a look at it for 30 seconds? And if anybody can spot a pattern, can you raise your hand and let me know? Oh, Jensen, yes, very fast. What is your pattern?
I think I saw 3 times 4 is 12 minus 7.
Oh, okay. So what you're saying is that you take 3, you times 4 first, then later you take 3 plus 4 equal to 7, then 12
Then 12 times
minus 7 is 5.
Equals to 5.
Okay,
and
it
then
works.
5 times 6, 30. 30 minus 11 is 19.
You got it already lah. Well done, Jensen. Good job. Okay, so students, as you can see, okay, we just write down. Okay, you have to do your working. Say 3 times 4 equals 12, and 3 plus 4 equals to 7. And then you can write down, you say, therefore, 12 minus 7 equals to 5, and that gives you 5. You must test whether it works for something else as well. So let's just test whether it works for 5 and 6. 5 times 6 equals 30, and 5 plus 6 equals to 11. Then you have to write down, therefore, (30 minus 11 equals to 19. So now you know it works. Okay, so now you know it works. Then you go on, you continue the pattern. They ask you, what is 2 times 2 star 3? Everybody, can you type your answer in the chat? What is 2 star 3? Type your answer in the chat. Ah, very good. I saw some correct answers already. Well done. Yes, Brian, Jaros, Jensen. Jun Chen, how about you? Okay, let me ask Jun Chen. Hi, Jun Chen, are you there? Okay, tell me what's the pattern. Oh, do you know what's the pattern, Jun Chen?
No.
Very good, Jun Chen. Okay, so you told me that 2 times 3 is 6, 2 plus 3 is 5, and therefore 6 minus 5 gives you 1. You are totally correct. Good job, everyone. Okay, now let's move on to the next one. So students, they ask you to find the area of the quadrilateral. So what is a quadrilateral? Anything with 4 sides. Okay, so this is an oddly shaped quadrilateral. It's not a square, it's not a rectangle. They ask you to find the area. Do you know any formula that you can use to find the area of such an oddly shaped quadrilateral? I don't think so. So what must you do, students? You must really use your imagination. How do you visualize this? Okay, why not I give you 2 minutes. Let's see if anyone can find the area of this quadrilateral. Type your answer in the chat, okay? So I have an answer from Brian. Let's see if he's correct. Now, some of you might be thinking, okay, why don't we why don't we try to cut them into triangles? Because you recognize triangles, you know the formula of finding the area of a triangle, right? But if you cut them into triangles, you don't even know what is the height. What is the height of this triangle? Or you might not even know what is the height of this triangle. So students, what is the best way to do it? Since Brian is the only one who gave an answer, let me ask Brian. How did you do it, Brian?
Because the side of the triangle,
Yes, 13.
the side
Yeah.
is the 13 is the same as the 13 on the top,
Yes.
and the 12
Yes.
is same as the bottom one.
Yes.
So it could fit like at the other side.
Very good. So you actually move the entire triangle here, right?
Yeah.
You are correct. Well done, Brian. Good job. Okay, so students, look. You have the same length here, and you also have the same length here. Can you just imagine, you just move this here, it's going to be 12 cm, correct or not? And the 13 cm is going to be in line with this. So you can actually fit the entire triangle over here. So you shift the triangle here. What do you get? So you get a square. Therefore, Brian, you are correct. The area equals to 144. Well done, Brian. Good job. Okay, so students, look. This is how you visualize. Okay? Try to cut and paste. Remember, whenever we did geometry, I always tell you, cut and paste, move things around. Okay? You don't have to keep things where they are. You can actually move things around. So that's how you do it. Any questions, students? Okay, now let's try the next one. Now, this has got to do with fractions. Students, let me revise with you. Whenever you see a fraction, what is the meaning of this line? This line means divide. Therefore, if you see a division, you can actually write it as a fraction, 2 over 3. Correct, students? So let me give you a hint. Write all of them as a fraction, then it is going to be very easy for you to solve it. I give you 2 minutes. Type your answer in the chat. Your time starts now. Okay, everyone. Now, fractions is a very important and very basic topic that you need to know in any exam, because fractions will always appear in any exam. So remember, we have learned KFC, right? So we have to use KFC. Not only must we write this as a fraction, we also have to use KFC. So let's write this down. 1 divided by 2/3 divided by 3/4 divided by 4/5 divided by 5/6. Okay, so now we have everything written down as a fraction, but don't forget to keep, flip, and change. So you keep this, you flip this upside down, and you change it to a multiplication. So you keep on doing this for all the fractions. Okay, you must use KFC. As long as there's a division, you have to keep, flip, and change. Now what do you do? Now do you notice that you can simplify this? 3, 3, 4, 4, 5, 5. And don't forget, you can also simplify this. 6 divided by 2. And therefore, the answer is 3. Well done, Jun Chen. You got it correct. So, students, anyone have any questions about this? Let me ask Brian. Brian, where do you go wrong? You forgot to KFC?
No, I just I forgot to divide one more time.
Oh, you forgot to simplify, is it?
Yeah.
No wonder. Okay. Now, at least now you know where you went wrong. So, students, anyone have any questions about this? Remember, whenever you see a fraction, the line means divide. So you can write it as a fraction. Whenever you see a division, you can write it as a fraction, but you must also KFC. Okay? Now let's take a look at this. Fractions again. Okay, before you do this, before you do this, let's do a small experiment first, okay? Students, I want you to observe this. If you look at this, the answer is 1 over 4. I mean, it's pretty simple, right? What about this? 1 over 4 times 7. Then you get 1 over 28. Correct? But is there another way that we can get 1 over 4? Okay, let's take a look here. Can we get 1 over 4 by doing this? Okay, students, when you see 1 over 1 times 4, can I write it as 1 over 1 minus 1 over 4? Let's see if I can. The answer will be 3/4. But actually, the correct answer should be 1/4, right? So looks like this is wrong. Looks like this is wrong. What about this? 1 over 4 times 7. Can I rewrite it as 1 over 4 minus 1 over 7? If I do this, then I'll get 3 over 28. But the correct answer is supposed to be 1 over 28. So students, what must I do to make it 1 over 28? I must remember to divide by 3 or times 1/3. Students, if I times 1/3, right, do you notice now I will get the correct answer? Correct? So actually, you know what? What we can say is, we can say that 1 over 1 times 4 equals to 1 over 4 minus, 1 over 1, equals to 1/3 of 1 over 1 minus 1 over 4. Okay? And this will give you 1/4. Correct? And what about 1 over 4 times 7? This will give you, you can actually write it as 1/3 times 1 over 4 minus 1 over 7. And that will give you 1 over 28. Okay? So students, what I'm trying to show you is that when you see a number like that, you can rewrite it 1 over 1 minus 1 over 4. However, you ask yourself, is there a gap? There is a gap between the numbers. The gap is actually 3. If the gap is 3, make sure you divide it by 3 so that you can close up the gap and get the correct answer. Okay? So students, having known that you can rewrite it like that, why don't I give you 2 minutes? Can you try to solve the question? Okay, your time starts now. Type your answer in the chat, please. Now, let's take a look at the answer. Now, students, this pattern will continue. Okay, so no matter what, for this and for this, you can also write them the same way. So now that we know the pattern, okay, let's move the pattern low. Oops. Okay, I'm going to move the pattern away. Okay, this is just the pattern that we have spotted. So I'm going to put it at the bottom. Okay. So how, using this pattern, how are we going to solve this, right? Now let's look here. We know that 1 over 1 times 4 actually equals to 1/3 times 1 over 1 minus 1 over 4. Okay? So I'm going to write down 1/3. Times 1 over 1 minus 1 over 4. But not only that, 1 over 4 times 7 is also equal to 1/3 times 1 over 4 minus 1 over 7. So I can just continue because I already have the 1/3 here. So I continue 1 over 4. Sorry, this is a plus, plus 1 over 4 minus 1 over 7. Then you can continue this also. 1 over 7 minus 1 over 10, correct? So actually, I'm just going to put a dot, dot, dot. because this pattern continues all the way until the last number 1 over 16 minus 1 over 19. So as you can see, students, the 1/3 can apply to everything. So now what are you left with? Do you notice something? Do you notice that 1 over negative 1/4 plus 1/4 equals to 0. So you keep on cancelling until you're left with the first number and the last number. So what are you left with? You're only left with 1 over 1 minus 1 over 19. Okay? And then you are left with, what is 1 over 1 minus 1 over 19? 18 over 19, right? So you can simplify, divide by 3, divide by 3. Your answer will be 6 over 19. Well done, Brian. You got it correct. Good job. How about the rest of you? Anyone have any questions about this? Okay, so you must spot a pattern. Okay, students, when you spot a pattern, then you can cancel out all the fractions and your answer will be so much more simple, simplified, right? Any questions, students? Raise your hand. Which part you don't understand? Okay, now let's try the next one. How many triangles are there in the figure below? So students, please, when you calculate triangles, you don't only count the small triangles. What about the bigger ones? There are some bigger triangles here as well, right? There are also some there's different size. There are triangles of different sizes. So you must make sure you count the triangles of all the different sizes. So what are those triangles? Okay, let's talk about the triangles. Okay, I'm going to draw a table. Okay, then we are going to say wait. Okay, I'm going to write down parts and I'm going to write number of triangles. 1, 4, 9. Then we're going to say total. Now let me tell you what it means, okay? It means that how many triangles are made up of one part? What do you mean one part? That means it is only one unit like that. One small triangle. How many triangles are only made up of one triangle? Go and count them. How many triangles are made up of 4 parts? There. This triangle is made up of 4 parts, right? Can you see 4 triangles joining together to make one triangle? This is also another one, right? This is also another one. So please count all of them. And how many triangles are made up of 9 parts? This is made up of 9 parts, right? So count all of them and add up the total. Type your answer in the chat. Your time starts now. So everyone, I saw your answer. Let's count how many there are, okay? So the triangles that are made up of one part, very easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 14 of them, right? So let's count 14. Now, what about those that are made up of 4 parts? 1, 2, 3, 4, 5, or maybe I use another color lah. 5. Any more? You also have to count the upside down triangle, okay? 6. Can you see this upside down one? 6. So there are 6 of them. Now what about those with 9? Those with 9 is over here. 1, 2. So now you add everything together, you get 22 triangles all together. Well done. I think Jun Chen forgot to count the upside down one, right, Jun Chen? Okay, very good. The rest of you got it correct. Well done. Now let's try the next one. How many ways are there to distribute 15 bananas to 3 monkeys? Now students, if you do it, you can either do it the long way or the short way. Okay, if you want to say that there are 3 monkeys, A, B, and C, and you want to distribute 15 bananas to them, you can of course make a list. You can just write down, let's say monkey A got 1 banana, the other guy got 1 banana, so you have 15 bananas, so the other last guy must have 13. So this will make 15, right? So let's say you keep monkey A as 1, then the other 2 guys will get 2 and 12, 3, 11, 4, 10, 5, 9, blah 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 blah. Gonna write down such a long list, and then after that you say monkey A has 2, then this guy has 1 and 12, 2 and 11, 3 and 10. Then you're gonna make a long list, and I don't know how long you're gonna take. Maybe you're gonna take forever. So I'm not gonna use this method, obviously. Anyone have a shorter method besides making a list? Anyone can think of a short method to do this? How many ways are there to distribute 15 bananas to 3 monkeys? Nobody knows, ah? Okay, maybe when I start drawing this, you might start to know. Okay, let me draw this, okay? If anyone suddenly realize which method to use, raise your hand. Does anyone realize which method I'm using? Anyone? Taught you this before. So yes, Jaros, which method did I use? Which method are we using? Oh, your microphone not working. Never mind, later you try to reconnect your microphone, okay? Jensen, what method are we using?
Stars and bars.
Very good. We are using stars and bars. Okay, so students, I have drawn 15 stars over here. We have drawn 15 stars here. So what are we supposed to do? We just need to draw 2 bars. 2 bars. Okay, so for example, if I draw a bar here and I draw another bar here, what does it mean? That means monkey A has 4, monkey B has 5, and monkey C has 6. And that will give you 15 altogether. No matter where you draw your bar, okay? Even if I draw it like that and like that, you will still have 15 bananas no matter what. Monkey A has 1, monkey B has 1, monkey C have 13. So there's no matter where you draw your bars, it will always work. Okay, so if I draw like that and like that, that means monkey A has 10, 4, and 1. 10, 4, and 1. So that's a different way to distribute the bananas. Correct. Okay, so let's just okay, I'm just going to draw an example like that. Okay, that means monkey A has 3, monkey B has 6, the other guy has 6. So that will give you 15 anyway. So students, the question now comes, how do we calculate this? Okay, so you ask yourself, in between all the stars, how many gaps are there? Can you type in the chat, how many gaps are there in between 15 stars? Can you type your answer? How many gaps are there in between 15 stars? Correct, Jensen. There are 14 gaps in between 15 stars. Okay, so why do I ask you this? If there's 14 gaps in between the stars, that is the number of places that I can draw my bars. So, how many ways are there to do it? Okay, so number of ways. You've asked yourself, how many places can you place your first bar? There's 14 places. There are 14 spaces for you to draw your first bar. So let me write 14. Then after you draw your first bar, you are left with 13 spaces, 13 gaps. So there's 13 places that you can draw your second bar. So, but then you must ask yourself, does it matter whether this bar comes first and this bar comes second? Or maybe this bar comes first and this bar comes second? It does not matter, students. Which bar comes first doesn't matter. You're still going to distribute the 15 bananas to the 3 monkeys, right? So you divide by 2 to get rid of the different order where you place your first bar and your second bar, or your second bar and your first bar. It doesn't matter which bar comes first. And that is how you solve it. Okay, so you divide this, you get 7. So the answer is just 7 times 13, 91. There are 91 ways to distribute 15 bananas to 3 monkeys. Okay, students? Isn't this a very, very quick and efficient way rather than making a long list and taking forever? Okay? Any questions about this, students? So it's all about drawing the bars. You ask yourself, where should you draw the bar? There's 14 places for you to draw. And once you draw your first bar, you're only left with 13 places to draw your second bar, right? Then you divide by 2 to get rid of the permutation. Alright, let's take a look at question 7. This is very basic, students. This is just finding the area of a square. I'm sure everybody knows how to find the area of a square, but you just need to be careful. Which one is shaded, which one is not shaded. Do your workings and give me your answer. Your time starts now. Well done. I saw everyone's answer. Now let's see who's correct, okay? Students, can I ask you this? Can you type in the chat? Can you tell me what kind of numbers are all these? What kind of numbers are all these? Type in the chat. Very good. You're correct. Square numbers. Yes, these are square numbers. Why do we call them square numbers? Because 1 to the power of 2, 1 times 1 is 1. 2 to the power of 2 is 4. 2 times 2 is 4. 3 to the power of 2, 3 times 3 is 9. 4 to the power of 2, 5 to the power of 2, 6 to the power of 2, 7 to the power of 2, 7 times 7, 6 times 6, 5 times 5, 4 times 4. These are all square numbers. Why do you call them square numbers? Because they give you the area of a square. They give you the area of a square because the side length of a square is the same. So 5 times 5, 25. Can you see? This is a square number, right? So students, we are going to make use of square numbers here to make our workings easy. So, firstly, they say that you have the biggest square has a side length of 5. So if you want to find the area of the biggest square, then it is 5 to the power of 2. That is the side length of the biggest square. But do you notice that how do you find the shaded area here? You must take the big square minus, okay, you must take the biggest square minus away the smaller square. That's how you find the shaded area, right? So don't forget, you must minus the smaller square. Then let's look at the third one. The third shaded area, but don't forget to minus the smaller square. And don't forget to add the smallest one in the middle, right? So after you do this, what is your working? 25 minus 16 plus 9 minus 4 plus 1. And if you add them, if you work it out, you will get an answer of 15. Ta-da! That's it, students. That is the answer. So well done. I can see that Jun Chen got it correct. Nobody else. Okay, so students, that's how you do it. Any questions? Brian, where do you go wrong? Add wrongly, yeah.
Yeah.
Oh, careless. Okay. Okay, so students, just be careful when you do your calculations, okay? This is supposed to be a very easy question, right? Because everybody knows how to find the area of a square, what? Okay, so just please don't be careless, huh? Now let's move on to the next one. Question 8. You have two bags, bag A and bag B. Each of them have 8 black marbles and 8 red marbles. So Jerry took 4 black marbles from bag A and placed it into bag B. Now the question comes. What is the minimum number of marbles that Jerry must transfer from bag A back to bag B back to bag A without looking? Okay, that means he cannot choose the color. He's covering his eyes like that. He cannot choose the color. And he must just grab some marbles and transfer it from bag B back to bag A to ensure that there must be at least 8 black marbles in bag A again. So students, let me draw it out for you. You have bag A and you have bag B. Currently, what happens is that Jerry transferred 4 black marbles from bag A to bag B. So let's look at the ratio of black to red marbles. There are going, you took 4 black marbles from bag A. That means you have 4 black marbles left. And in bag B, you have 12 black marbles. Okay, because both of them started with 8 each. Jensen, you have a question? You raise your hand.
Does the 8 marbles mean bring 8 marbles back to bag A, or
No. Okay, let me explain.
like you put there must be at least 8 marbles in bag A?
You are correct. There must be at least 8 marbles in bag A. Very good. So let me explain. So students, right now what's the situation? Bag A have 4 black and 8 red. Bag B have 12 black and 8 red. That's right now, that's the situation. So now what's going to happen? Now you are Jerry. So Jerry, what must Jerry do? He must stick his hand into bag B, stick his hand in, grab some marbles, and transfer to bag A. Now, what is his ultimate goal? His goal is that in the end, right, instead of having 4, you must have at least 8. Or more lah. More than 8 is fine lah. At least 8. You can have 9, you can have 10, you can have, up to you lah. You can have anything. But you must be at least 8. There must be at least 8 black marbles in bag A again. So, if you're very lucky, if Jerry is very lucky, because he's closing his eyes, right? If he's super lucky, he just need to take 4. He take 4 from here, right? And then he just put it back here, lor. Then you have at least 8 already, what? But do you think he's so lucky? Students, you must think of the worst case scenario. Understand? What is the worst case scenario? What if you take 4? What if you take 4 and all of them are red? Then how? If you take 4, all of them are red. Will you manage to get 8 black marbles in bag A? No, you will not. So the question is, at least how many marbles must he take to guarantee that after taking, you will have at least 8 black marbles in bag A. Think about it. Again, I give you 2 minutes. Think about it. Type your answer in the chat. Your time starts now. How many marbles must you take with your eyes blindfolded? So students, I can see different answers from some of you. Some of you say 12, some of you say 16. Now, you ask yourself, if you're super unlucky, what will happen? If you're super unlucky, you know what will happen? You are going to take all the red color marbles. Then you're going to transfer here. Then you're not even gonna get what you want, right? But what does that mean? That means you need to be prepared for the worst case scenario. You must be prepared to take all the red marbles, because that's going to be the worst case scenario. Prepared to take all the red marbles. So let's write down number of marbles that you must take. All the red marbles. Get ready to take all the red marbles, because you must pretend that you're very unlucky. When you take, it's all red, which is not what you want, right? Then after that, finally, you are going to take 4 black marbles. Okay, if you take all the red, then later you take 4 black, then you can make sure that there's at least 8 black marbles. So the answer is 12. Well done, Brian, Jaros, and Jensen. You got it correct. Okay, so students, remember this. This is if you're very unlucky, you took all the red. Then after that, you take the 4 black. Okay? So always remember the worst case scenario. Okay? Remember the worst case scenario. Now let's try another one. Question 9. So here you have a number sequence, and from the third number onwards, each number is the ones digit of the sum of the previous 2 numbers. Okay, students, everybody look here. Do you recognize this or not? Students, can you tell me, type in the chat, what is this sequence called? Does anyone know the name of this number pattern? What is the name of this number pattern? Type in the chat, everyone. Anyone knows? Very good, Brian. Okay, this is called the Fibonacci sequence. It's a very famous number pattern, okay? How do you get the Fibonacci sequence? You start with 1 and 1, then you take 1 plus 1 equals to 2. Then you take 1 plus 2 equals to 3. Then you take 2 plus 3 equal to 5. So you keep on adding the previous numbers in order to get the next number. Now what is this question saying? This question is a little bit similar to the Fibonacci sequence, but they are not taking the complete number. They are only taking the ones digit. Okay, students, look here. Ones digit. What do you mean by the ones digit? Okay, so for example, when you take 1 plus 3, you get 4. 3 plus 4 is 7. 4 plus 7 is 11. But you don't write the number 11. You just write down the ones digit, which is the last digit. Okay, then you continue this one. 7 plus 1 is 8. 1 plus 8 is 9. 8 plus 9 is 17, right? 8 plus 9 is 17. But you don't write 17, you know. You just write down the ones digit, which is the number 7. Okay? So this is how it works. Very similar to Fibonacci, but you're only writing down the ones digit, okay? So from here, right, they need you to spot a pattern, and they want you to find the sum of the first 40 numbers. Find the sum of the first 40 numbers. Okay, I give you 2 minutes. Think about it. Your time starts now. Alright, looks like Jaros gave a very good explanation. So what did Jaros do? Okay, students, let's take a look. 1, 3, 4, 7, 1, 8, 9, 7, 6. So continue adding. 7 plus 6, 13. And 6 plus 3, 9. 3 plus 9, 12. 9 plus 2 is 1. 9 plus 2 is 11. 2 plus 1 is 3. 1 plus 3 is 4. Hey, look, it's already repeating. Okay? Can you see it's already repeating, students? Okay, come, let me move this to the center. Okay, so students, do you notice something? The pattern, right, repeats every 12 numbers. Okay? Okay, so we can say that repeat. Okay, it's a recurring pattern. Recurs every 12 numbers. Okay, or you can say that there's a repeating cycle of 12 numbers. So there's a repeating cycle of 12 numbers. Why don't we add all these 12 numbers together? Okay, you add all the 12 numbers together. Ooh, okay, so sum of 12. Let's add all of them together. 1 plus 3 plus 4, that's 8. Let me add them up. 8, then 15, 16, 24, 33, 46, 49, 60. Okay, so you add everything together, you get 60. So once you get 60, right, what do? You want 40 numbers? So how many cycles are there? Number of cycles. You want 40 numbers, but they repeat every 12 numbers. So you will get 3 cycles, but you have 4 numbers left over. So therefore, what's the total sum? You have, each cycle is 60. Each cycle of 12 number add up to 60. You have 3 cycles. Okay? Don't forget to add the extra 4 numbers at the back. Then you will get the final answer. There you go. Okay? So that's how you do it, students. The answer is 195. Okay, can I ask Brian? Brian, you also gave an answer, right? So actually, where do you go wrong?
I think I calculated the sum of the 12
Wrongly.
wrongly.
Addition error. Okay. Next time, just be careful, okay? Thank you, Brian. Jensen, I saw your answer as well. Very good. Okay, so students, anyone have any questions about this? Alright, now let's try question 10. Geometry again, students. Remember what I told you? Remember I told you you should cut and paste, move things around? Okay, please use your visualization skills to cut and paste the shaded area. Then you'll be able to get the answer. Come, I give you 2 minutes. Your time starts now. Okay, students, since you are stuck, I give you a hint. Okay? Now, my hint is that this is a square. If this is a square, means these 2 sides are the same length. So, would it be too unrealistic if I were to join this triangle to this side over here? Think about it. Can you shift the bottom triangle somewhere? Okay, think about it. Okay, that's my hint for you. I give you 1 more minute. Let's go. Don't worry. Come, let me help you, okay? So, Junchen, let me ask you this. You agree that these 2 sides are the same, right?
Yes.
Because it's a square, okay? So, Junchen, if I were to just rotate this triangle over here, now my first question to you is, do you know the length of this side?
No.
Don't know, right? So if I were to rotate this triangle here, do you think it will become something that looks like that?
No.
No, right? Because as you can see, this side is a little bit shorter. So maybe if you rotate it, it might look something like that. it might look something like that, right? So, does it matter how long is this side? Okay, let me ask you the next question here, okay? What is this angle here?
90 degrees.
Can you tell me what is the sum of this angle plus this angle?
Right.
Sorry?
180.
I know the entire thing is 180, but I'm asking you what is A plus B?
90 degrees.
90 degrees, you are totally correct. So if I rotate the triangle here, right, and then this whole part becomes shaded, right? What is the angle here? Do you agree?
90.
Yes, because A plus B is 90 degree. So that's the case. Then this is 47. So this must also be 47. You agree? So now what do you have? What do you have here?
Right angle triangle.
Yes, you have a right angle triangle. So that means the two shaded part, when you add together, it becomes a right angle. Alamak. Okay, let me redraw again. Stupid iPad. Okay. So these two shaded part add together will give you a right angled triangle. So therefore, how do you find the area of the shaded part?
Half times 86 times 47.
Correct. Very good. Okay, so then you simplify this. So then the answer is 43 times 47, which is 21 cm square. So how? Do you find it easy now?
Yes.
Very good. Well done, Jin Chen. Okay, so students, you see, always think of how you can cut and paste, rotate it here, move it. You just shift the shaded area, you can combine them, you can get a right angle triangle, okay? Any questions? See, it's so easy, right? At first you're stuck, but now once you shift it, suddenly becomes so easy, huh? Okay, let's try the next one. Now, over here, you have a rectangle with the width of 3 cm cut out. So don't forget you started with a rectangle. And then you cut out a rectangle. A very skinny rectangle, it got cut out. The remaining area is 180. This is the remaining area. Find the side length of the square. So they want you to find out what is the side length of this square. Okay? So students, why not we think about square numbers? Remember just now we talked about square numbers? Let's write down some square numbers. Okay, let me ask Jensen. Jensen, can I ask you? Jensen, do you agree that the area of any square is always going to be a square number?
Yes.
Yes, the area of any square is a square number. Do you think that the area of this entire square could be 1, 4, 9, 16, 25? Could the area be any of these numbers? Because this is already 180 leh. So do you think that it cannot be, right? Too small, right?
No, wait, too small.
So you need to write down the square numbers which are bigger than 180, correct?
Yes.
Okay, so let's write down some numbers, square numbers that are bigger than 180. 13 times 13 is 169. Oh, 169 is still too small. How about, okay, never mind, let's write down 169. Then 14 times 14, 196. 15 times 15. Okay, then it goes on. Now, do you think it can be 169?
No.
Too small, right?
Yeah. 196.
196
Damn.
possible lah, possible, right? So let's try, okay? Why not we try 196 minus 180 left with 16. Do you think the area of
No,
this...
cannot.
Why?
Because 60 is it's only divided by 2, 8.
Very good. So you cannot be a multiple of 3, right?
It's not.
Okay, so we reject this. Then could it be 225?
5, there's a possibility.
Do you think 45 can be divided by 3?
Let me say, yeah.
Yes. Okay, because 45 can be divided by 3. Therefore, what is the side length of this? Therefore, what is the side length of this square?
10.
Therefore, the side length equals to 45 divided by 3. Correct. Very good. Well done, Jensen. So how was this easy?
Yes.
Yes. Okay, so students, make use of the square numbers. Remember, I told you that square numbers, why are they called square numbers? Because they give you the area of a square. So you just need to write down those area of the square which is bigger than 180. Then you can minus 180 and you see which one is divisible by 3. Okay? And let's move on to our last question of the worksheet. Okay, so students, at a party, 2 children shared a can of soft drink. 3 children shared a pack of potatoes. And 4 children shared a tub of fruit jelly. There are 52 items that were consumed altogether. How many children were there at the party? Now let me give you a hint. What does it mean when they say 2 children share a can of soft drink? Now, if 2 children share a can of soft drink, that means each child drank half a can of soft drink. Correct? Then if 3 children share a pack of potatoes, that means each child ate 1/3. And over here, each child had 1/4 of a tub of fruit jelly. Okay, so that's my hint to you. Can I give you 2 minutes to try to solve this? Your time starts now. Now, everyone, let's find out. Because you already know that each child drank half a can of soft drink. That means they make use of half. Now, what is the meaning of item? 52 items. So, for example, 1 can of soft drink is 1 item. 1 pack of potatoes is also 1 item. 1 tub of fruit jelly is also 1 item. So, what is the total number of items that each child make use of? Okay, so number of items per child. So you already know that 1 child used half of a soft drink, 1/3 of something else, and 1/4 of something else. So what is the number of items used by the child? Okay, you make the denominator the same. Then you have 6, 4, 3. That means each child make use of 13/12 of an item. So if 52 items were used altogether, how many items are there? How many children are there altogether? 52 items divided by the number of items that each person used. Right? Then you must KFC. Keep, flip, and change. Divide by 13. Divide by 13. Your answer will be 48. Well done, Brian. You got it correct. Good job. So students, it's quite simple. Now let me explain to you something. If I tell you that at a party, each child drank 2 cans of Coke. given that 20 cans were drunk in total, how many children are there? Very easy, what? The total number of cans divided by the number of cans that each person drink. There's 10 children there. It is the exact same concept here, right? The question told you that 52 items were consumed altogether. Correct or not? So each person consumed 13 over 12. So you just take 52 divided by 13 over 12, and that will give you the correct answer. Okay, it's the same concept. Just that this one makes use of fractions. This one makes use of fractions. That's why maybe you found it more difficult. Jensen, question?
But, Coach, I thought you forgot to simplify the 4 and the 12.
Where?
The 4, on top of the 52 and the 12.
No lah. This is numerator. This is numerator. You must multiply. 4 times 12, 48.
Okay.
You can only simplify if it is a numerator and a denominator, which is... Okay, let me explain. Is 52 a fraction?
It can be.
Nah, so you see numerator and denominator, you can simplify, correct or not? But how about this? This numerator, how about this? This also numerator, right, Jensen? So can you simplify? Cannot simplify, right or not, Jensen?
Yes.
Okay. So it is 4 times 12, 48. Alright, students, well done. We have completed the worksheet. It is time for your bonus question. Let's take a look at our bonus question for today. There we go. Bonus question. 100 soldiers stood in a straight line. They take turns to call out the number 1, 2, 3, 1, 2, 3, 1, 2, 3, okay? Then after that, once they are finished with the 1, 2, 3, and then starting from the right. So over here they start from the left. Okay, let me highlight. Starting from the left, they call 1, 2, 3, 1, 2, 3, 1, 2, 3. Starting from the right, they call 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. How many soldiers called out the number 3 twice? So students, how do you do this? Okay, you must think about it. What is the lowest common multiple of 3 and 4? Can you type your answer in the chat? What is the lowest common multiple of 3 and 4? Correct, 12. Very good. So let's write it down. Okay, I'm going to make a table, and we are going to observe 12 soldiers. Okay, let's just observe 12 soldiers. So imagine we have 12 soldiers. Sorry. Okay, so let's say this is from left to right. They count 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Then what if you go from right to left? If you go from right to left, you also start off from 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So students, do you notice that in every 12 soldiers, who is the person who call out the number 3 twice? Only one person. In every 12 soldier, only one person call out the number 3 twice. So can you tell me how many soldiers out of 100 soldiers, how many of them call out the number 3 twice? Type your answer in the chat. Come, your time starts now. So Junchen, my first question to you. Every 12 soldiers, how many people call out the number 3 twice?
1.
1. Then in 100 soldiers, right? Can you tell me how many groups of 12 soldiers are there?
8.
Very good. Remainder 4. Okay. Does it matter whether there's a remainder 4?
No,
Why?
because the extra 4 people never said the number 3.
Very good. Because this is the 6th person. Only the 6th person is the one who shouted the number 3. So it most likely he will not shout the number 3 again. So very good. So if there's 8 groups, then can you tell me how many soldiers shouted the number 3 twice? There are 8 groups,
Eight.
right? 8. Yes, correct. Well done, Jin Chen. So how you understand this question?
Yes.
Well done. Thank you, Jin Chen. Okay, so students, any of you have any questions about this? Raise your hand. So we made a list, right? We made a list of soldiers, right to left, left to right. And we also use the number 12. We actually wrote down 12 soldiers because the lowest common multiple is 12. Okay? So that's how you solve this question. Well done today, students. Not only have we finished the worksheet, we have also done the bonus question. Yes, Jensen, you have a question?
A question for just now, that question.
Yes.
Why you write it the 6? I thought it's the 7s.
6 what? You count now. Or you counting from left to right?
Wait, eh?
You counting from there? I'm counting from here. Yeah,
Oh.
yeah, you know why I'm counting from here or not?
Oh yeah, that's true.
Yeah, you know why not? Because I count
Yeah,
from...
I know.
Yeah,
Sorry for the left.
correct. Okay, so students, well done today. We have finished the bonus question as well. So do your revision. I think I need to point out something lah. I noticed that all of you didn't really know how to visualize the geometry questions. Okay, so please make sure you know how to visualize. Go and revise your geometry questions that we did today. And one more thing is the fractions. Remember, even the one that I was expecting you to get it correct, which is a divide, the one which involved the KFC, you also didn't get it correct. Only Brian got it correct. So everyone, please, fractions are very important. Please do your revision, practice your fractions. Do you know that fractions take up a very big weightage in your exam? You must know your fractions. Okay, students? Do your revision. Hopefully tomorrow you perform better. I'll see you tomorrow. Bye, everyone. Bye, Jensen, Jaros, Jin Chen, Brian. Bye.